Have you ever wondered why your hair starts to thin, or why a cut on your skin seems to take forever to heal? Well, the answer isn't just in some expensive cream. It's actually part of a huge, hidden battle happening inside your cells. And today we're going to find the secret switches that control it all. So think about this for a second. What if everything you needed to regrow hair, to heal your skin faster, was already there, locked away inside your own cells? What if we just needed to find the key to turn it all on?
You know, for so long, we've been trying to fix things like hair loss and skin damage from the outside in. We use all these creams and serums and treatments. And it's a huge deal, right? We're all looking for that one thing that's going to work better, something that actually gets to the real root of the problem.
Well, it turns out the key might not be some new miracle ingredient that we slap on our skin. The real magic is in understanding and maybe even controlling a group of super powerful messenger molecules that our bodies are already making. Okay, so let's get into the science of it because this is where things get really interesting. We have to talk about these lipid compounds called prostaglandins. Just think of them as tiny little messengers running around inside you. But here's the plot twist. Not all of these messengers are on our side. It's a tale of two molecules. So what are they, really? Prostaglandins are basically tiny, powerful directors for your cells. They're made from fats, and they shoot out signals that tell your body to do all kinds of stuff, from cranking up inflammation when you're hurt to hitting the brakes on cell growth. They're a huge deal. And this is where we see the two sides of the story, a real biological tug of war. On one side, you've got prostaglandin D2, or PGD2. This is the stop signal. They find this stuff in high levels on bald scalps, and its job is basically to tell hair follicles, all right, party's over, shut it down. But on the other side, we have our hero, prostaglandin E2 or PGE2. This is the go signal. It wakes up the stem cells in your hair follicles and tells them to get growing. So the takeaway here is pretty clear, right? If we want to boost hair growth, if we want to repair our skin, then PGE2 is the molecule we need to be rooting for. It's the engine that literally drives regeneration. And hey, don't just take my word for it. This isn't just some wild theory. Check out this quote from the scientific journal Theranostics. They flat out say that PGE2 is a master regulator. It activates our own stem cells, it controls our immune response, it even helps build new blood vessels. I mean, it is an absolute powerhouse for repairing tissue. Now, this diagram might look a little complicated, but the process is actually beautiful. So when your tissue gets damaged, right, these enzymes, you see them there, COX-1 and COX-2, they get to work. They take a fatty acid and convert it into our hero, PGE2. That PGE2 then sips over, latches onto receptors on other cells, and is basically like, okay team, time to start repairing. And PGE2 is no one-trick pony. It's got a whole range of what you could call regenerative superpowers. It wakes up the stem cells for hair, it speeds up skin healing, it helps reduce scarring, it builds new blood vessels to bring in nutrients, it even helps calm down bad inflammation. It is truly the Swiss Army knife of regeneration. Okay, so you're probably thinking, if PGE2 is so amazing, why aren't we all just perfect regenerating machines? Well, that's because our hero molecule has a fatal flaw. Here's the catch. PGE2 is incredibly fragile. It has a super short lifespan in the body. We're talking just a few minutes tops. It's designed to be a rapid response signal. So it gets made, it delivers its urgent message, and then it's almost immediately destroyed. It's like a text message that self-destructs 2 seconds after you read it. And here is our villain, the culprit behind this whole problem. It's an enzyme called 15-PGDH, and its entire job, its whole purpose in life, is to seek and destroy PGE2. It literally hunts down our hero molecule, deactivates it, and shuts down that amazing regenerative signal way too early. So this problem led scientists to a really brilliant idea, a simple what-if question. If the bad guy is this overzealous enzyme, what if we could just stop it? What if we could block the villain from doing its job? And that's where these things called 15-PGDH inhibitors come in. These are molecules designed to do one thing, block that villain enzyme. And what's so cool about this is you're not adding some foreign chemical to do the work. You're just protecting the PGE2 your body is already making. You let it stick around longer so it can amplify your body's own natural repair signals. And this approach is a real game changer in the world of modern dermocosmetics. And the effect isn't small. Research shows that by blocking that enzyme, you can boost the local levels of PGE2 by at least double. Think about that. You are doubling your body's natural healing power. just by playing defense and stopping the good stuff from being broken down too soon.
So this changes everything. This new way of thinking is creating a massive shift in how we approach not just hair care, but advanced skincare too. We're finally moving beyond just covering up problems and into an era of true bioactivation, working with our bodies, not just on them.
So the big takeaway here is this absolutely fundamental shift in thinking. The future of skincare and hair care isn't about just masking the symptoms anymore. It's about sending the right signals to actively team up with our body's powerful built-in regenerative system. It's about working smarter, not harder.
It really leaves us with a fascinating question, doesn't it? Maybe the next giant leap forward in beauty and cosmetic science isn't about discovering some new exotic chemical at all, but about finally learning how to flip the switches and reactivate the incredible biological potential that's already inside every single one of us.